Welcome to the Explainer. All right, let's just jump right in. Today, we're exploring something truly colossal together. We're diving into the staggering engineering behind the Category J jackup rigs. These are essentially floating, self-elevating megastructures that were explicitly built to tame one of the most merciless maritime environments on Earth, the North Sea. 10,000 meters. Just think about that for a second. That's how deep these megastructures can drill down into the Earth's crust. And they do this while standing completely firm, suspended above the most punishing ocean conditions on the planet. Places where winter storms can easily capsize standard vessels. It's just incredible. So here is our roadmap for today. 1. Meet the Cat J class. 2. Legs, jacking, and foundation. 3. Power, people, and tech. And 4. Well control and barriers. Let's get right to it. Section 1. Meet the Cat J class, the ultimate North Sea solution. So the Cat J, specifically the Gusto MSC CJ70 design, is basically a supersized engineering answer to a very specific problem. The North Sea punishes absolutely anything that floats. To survive out there, operators needed a rig bigger and stronger than any standard jackup before it, and that means it has to live this fundamental dual life. First, it operates as a watertight floating barge, so it can be towed out to its location. Second, it literally jacks itself up out of the water on 3 massive legs. And third, it transforms into a rigid, fixed platform to drill completely motionless. If you get that transition wrong, well, you either can't float or you can't lock down to drill. Now, here's a great way to think about how these rigs work in practice. Think of a Boeing 737. It's the exact same certified baseline airframe, right? But different airlines use entirely different cockpits and cabin setups inside. The sister rigs in the Cat J class, like Askapot and Askeladden, work exactly the same way. They share that certified CJ70 baseline structure, but over time, they receive highly customized operational setups. So you always have to check the specific rig's configuration, not just the class as a whole. All right, moving on down, Section 2, legs, jacking, and foundation, standing on the seabed. So picture those massive 700-foot triangulated lattice legs. Where they physically meet the incredibly unpredictable ocean floor, you find what are called the spud cans. Now, the Cat J uses enlarged, skirted spud cans. It's exactly like how a snowshoe works. A snowshoe takes the weight of a human and spreads it over a wide area so you don't sink into deep snow. A skirted spud can does the exact same thing for the rig. It takes those thousands of tons of weight and spreads it over the soft seabed to resist sinking and sliding. But what happens if the seabed is deceptive? Well, that brings us to something called a punch-through. This is a catastrophic failure, where a spud can break through a hard crust on the seafloor and plunges into a much softer layer of clay beneath. This causes a sudden, incredibly uneven rig tilt. It is a terrifying hazard. And it's exactly why meticulous site surveys and highly disciplined incremental preloading are absolutely mandatory before every single operation. You just can't risk it. Okay, so how does this massive rig actually climb its own legs? It uses a rack and pinion climbing system. Imagine a highly coordinated house lifting crew, manually sinking multiple hydraulic jacks so the house frame doesn't twist as it goes up. The rig's jacking system does this automatically. It uses many independent variable speed drive electric pinion gears. They auto-level in real time, making dozens of micro-adjustments every single minute to make sure the load is perfectly distributed. But here's the catch. If those gears fall out of sync, you encounter RPD, or rack phase difference. This is a vertical mismatch between adjacent rack and pinion units on a leg. If one side climbs even slightly faster than the others, it risks extreme structural twisting that can literally destroy the leg. So the crucial takeaway here is this. An RPD alarm on the control board is an absolute hard stop. It is a golden discipline rule. You stop, you investigate. It is never, ever just a suggestion. That brings us to Section 3, power, people, and tech, the brains and brawn. Now, this is truly fascinating. Let's look at Askapot's landmark power upgrade in the fourth quarter of 2024. Most offshore rigs run kind of like a house on a backyard generator. They require constant diesel, and it creates a single point of failure. Askapot, however, was upgraded to act more like a grid-connected house. By pulling high-voltage AC shore power through the Martin Ling platform, it saves an incredible 20,000 tons of CO2 every single year. But, crucially, it still retains its dual diesel engine rooms as a mandatory, strictly regulated backup. Of course, when you have 140 people living on a rig, emergency evacuation is a primary concern. To handle this, the Cat J uses a record-breaking 81-meter Viking evacuation chute. Think of a high-rise fire tube where friction slows your descent. The Viking chute is made of non-flammable Kevlar and Nomax, but it has this zigzag design. This deliberately forces controlled speed through friction at every single bend, safely managing what is essentially a terrifying 25-story drop to the violent waters below. All right, let's talk drilling capability. The derrick has a massive 2.1 million pound hook load, but the real magic here is the Gusto MSC XY cantilever. Remember how an old dot matrix printer head moves in 2 axes to hit any point on a piece of paper? Well, the XY cantilever does exactly that, but with the entire drilling package. It moves over multiple well slots on a template, forward, backward, left, and right, all without moving the hull of the rig and without disconnecting any live high-pressure fluid lines. Inside the cyberbase, which is the digital driller's cabin, everything is controlled by screens and joysticks. But you know, this heavy automation brings a very real human cost. A regulatory audit by Havtel explicitly warned about, and I quote, high alarm workload and the risk of drillers losing their downhole feel for the well. Alarm fatigue is a massive, massive risk when you are heavily insulated by software from the actual, physical, vibrating reality of the drill string thousands of meters below you. To put it into perspective, think of the rig's Novo's automated drilling control software and its high-speed wired drill pipe telemetry, kind of like adaptive cruise control in a modern car. It's absolutely amazing for efficiency, and it drastically reduces your routine workload. But it dangerously risks eroding a driller's hands-on situational awareness. When the system hits an unexpected edge case and abruptly hands control back to a human, well, that human might react a bit slower because they've lost their intuitive hands-on feel for the operation. And finally, Section 4, Well Control and Barriers, Holding Back the Pressure. Out here, your primary barrier is the drilling mud. The rig circulates fluid from a huge 9,800-barrel mud system all the way down the hole. When that mud returns to the surface, it's full of rock cuttings. So to clean it, the rig uses a solids control system, 5 shale shakers, a desander, and a desilter. It works exactly like running pasta water through progressively finer kitchen sieves. Each stage catches what the last one missed, keeping the mud perfectly clean and the weight perfectly balanced. Now, if that mud fails, we rely on the blowout preventer, or the BOP. But unlike floating rigs that put the BOP down on the seabed, the Cat J is a jackup. That means its massive 15,000 psi BOP sits way up high at deck level. And because it's holding back up to 15,000 psi of pressure up in the air, the high-pressure riser pipe connecting it to the seafloor requires extreme, dedicated lateral support just to handle the intense structural loads and ocean motions. So this all brings us to the ultimate life-or-death engineering question for anyone working on this rig. If the primary well control barrier fails, what is the exact, non-negotiable sequence of defense to prevent an uncontrolled blowout? Okay, let's walk through this sequence. It is a strict 3-layer net. Layer 1 is the fluid mud providing hydrostatic pressure. That is your primary active barrier. Layer 2 is the mechanical surface BOP stock. That's your secondary emergency physical seal. And layer 3 is the cement plug. That is the permanent isolation barrier set once the casing is securely in place. 3 distinct layers, all built on the exact same well control philosophy. Which kind of leaves us stepping back to just marvel at the sheer, overwhelming scale of the Cat J class rig. We've got 10,000 meters of drilling capability, massive auto-leveling legs, and software controlling thousands of horsepower. But as automation continues to take over the drill floor, how do we ensure the human operator doesn't become the weakest link in this multi-million-pound chain? It really is a delicate, ongoing balance between heavy engineering, intelligent automation, and unwavering human discipline. Thank you so much for joining me for this explainer. I really hope this helped you structure your understanding of one of the most incredible machines operating in the ocean today. Catch you next time.